and just levitate.
Hi guys, so welcome ulit sa ating YouTube channel. Ito na yung lesson 15 sa ating Trigonometry. Ito yung topic na Fundamental Identities. So pag-usapan muna natin yung mga Fundamental Identities, yung Reciprocal, yung Quotient, saka yung Pythagorean Identities. Okay, so then apply ko muna siya sa mga solution. So wala mo na mangyayaring verifying or something na parang trigonal substitution something. Wala mo nang ganun. Pero before that, siyempre mag-explain muna about dito. So una, a conditional equation is true for certain values in its domain. So example, 2x plus 1 is equal to 9 and m squared minus 2m is equal to 3. So again, i-isolate lang natin yung mindset natin sa ano yung conditional tapos ano yung identity. Okay, so una, sabi nga si conditional equation is true for certain values in its domain. And example is 2x plus 1 is equal to 9 and m squared minus 2m is equal to 3. So ito ay equation in terms na meron lang part na kunyari may values lang sa domain na mangyari ay totoo siya. So for example dito, sa 2x plus 1 is equal to 9, magiging totoo lang to for x is equal to 9. So this is true. So when x is equal to 4, I mean, totoo yun. Okay, doon lang nasa-satisfy yung equation na to. Dito naman yung value na to is nagiging totoo siya pag yung value is m minus 2 minus 2m is for m is equal to 3 and negative 1, I think. Okay, so dyan naman siya true. So again, yung conditional equation, may certain values lang siya na true. So kailangan mo muna i-solve yung values. Tapos for example, tulad nga niyan, true lang siya for x equal to 4, then for m, dito naman, true naman siya for m is equal to 3, and m is equal to negative 1. So yun si conditional equation. So meaning, yung mga sinod natin last time, pag pinapahanap ko yung value ng x and y, or yung value ng x, yung quadratic, o yung system of equation. So conditional equation yung mga yun. Okay, kasi nga, sila ay true lang for counting values. Okay, so ngayon, ano naman sa identity? An identity is an equation which is true for every value in its domain. So example na to na identity, for example, meron akong k plus 1 squared is equal sa k squared plus 2k plus 1. So identity equation yan. Okay, so identity yan, I mean. So bakit sir? Pag nagpalit ako dito ng value ng k na 1, tapos dito value ng k na 1, equal yan. So sa kahit anong value ng k na ipalit ko yan, true yan. Okay, then another example. So for example, meron akong 2 times x plus 3. Ito ay 2x plus 6. So identity rin yan. Kasi nga, palit ako dito ng 2. Magpalit ako dito ng 2, so that is 2 times 5. Then ito ay 2 times 2, 4 plus 6. So dito ay 2 times 5 is 10. Ito ay 2 times 2, 4 plus 6 is 10. Okay, so kahit anong values na ipalit ko na x dyan, that is true. Okay, so likewise dito naman, hindi siya solvable. Bakit? Kasi dito, pag pinagsama-sama natin lahat siya, kunyari, tinira natin yung 0 lang sa left side, okay, or sa right side, I mean, lahat ng variable sa numbers dinala sa left side, pinag-combine, na mangyari lang 0 is equal to 0. So kumbaga, ang mangyari lang is, kaya nga siya parang identity equation. Yun yung parang pinaka-unique niya. Unlike dito, pag sinolve mo to, talagang may matitirang variable sa left side or sa right side. So whether linear yan, quadratic, or cubic, or quartic equation. So ganun yung mga conditional, tapos ganun yung identity. Ayun yung malaking pinagkaiba ni conditional sa ni identity. Ngayon, kaya nga, diniscuss ko yung identity na yan. Sa trigo, ganun din. So ibig sabihin ng identity, pag nakita ko yung k plus 1 squared, ito lang din yan, ibig sabihin. Kung makita ko si k squared plus 2k plus 1, ito lang din yan, k plus 1 is equal to squared. So meaning na identity, whether gamitin ko si left side or si right side, equal yan, equivalent yan. So kunyari lang, nakita ko lang si left side, alam kong dapat nakasettle sa mind mo na alam ko siya si k squared plus 2k plus 1. Basta pag sinabi ko siyang identity. Okay, so let's talk about the fundamental identities dito sa ating trigonometry. So we start with the reciprocal identities. So I guess na-discuss ko na to last time, pero syempre dadagdagan ko konti. Okay, so the reciprocal identities are, so una is cotangent theta is equal to 1 over tangent theta. So pwede yan i-manipulate. So ito, kaya naglagay ko ng space. Ito ay pwede ring tangent theta is equal to 1 over cotangent theta. So another identity yan. Another identity, cotangent theta tangent theta is equal to 1. So another identity yan. So count as 3. Dalawa yan. So pag nakita ko ng 1, so hindi sa lahat ng oras si Pythagorean identity siya. So possible na kunwari kailangan ko ng cotangent sa tangent. Ayan siya. Okay, next dito, similar case, yung secant theta is equal to 1 over cosine theta. Si cosine theta ay equivalent kay 1 over secant theta. And also, si secant theta times cosine theta equal to 1. Okay, so para at least mabawasan yung mga identities, yung mga natin. Next ito ay sin theta 1 is equal to 1 over cosecant theta. Then cosecant theta times sin theta is equal to 1. So again, sa kanila palang tatlo, naka-generate na tayo ng tatlong identities na baka maging useful sa atin. So that is the reciprocal identities. Okay, so again, reciprocal identities yung mga bagay na yan. Okay, next is the quotient identities. So if we have tan theta, so tan theta is just equivalent sa sin theta over cosine theta. Cotangent theta is cosine theta over sine. So tandaan yan. So where theta is any angle. So palit na kayo ng x, y, a, or kahit anong variable or kahit anong symbol, angle pa rin yun. Basta nasa loob ng trigonometric function natin. Okay, then the Pythagorean identities. So again dinadagdagan ko lang ng parang identities. So ito identities din yan. Reciprocal identities din yan. In general kasi ito sila. In general ito yan. So pwede ka rin magdagdag yan kung gusto mo mag-manipulate. Okay, next is the Pythagorean identities. So itong mga Pythagorean identities na to is na-derive lang talaga dito sa Pythagorean identities natin na sin squared theta plus cosine squared theta is equal to 1. So another tan squared theta plus 1 is equal to secant squared theta. Ito 1 plus cotangent squared theta is equal to cosecant squared theta. So dito manipulate natin kung gusto ko kunin si sin squared. Si sin squared theta is equivalent lang kay 1 minus square of cosine theta or cosine squared theta. Next, cosine squared theta is also equivalent sa 1 minus sine squared theta. Okay, dyan sila galing. Okay, next dito naman kay tangent. So manipulate natin kung gusto ko lang kunin si tangent. So if we have tangent squared theta, equivalent lang to kay secant squared theta minus 1. Next, kung gusto ko tira si 1, that is 1 is equal to secant squared theta minus tangent squared theta. Yun yung mga possible identities out of tangent squared theta plus 1 is equal to secant squared theta. Next is 1 plus cotangent squared theta, that is cosecant squared theta. So manipulate natin konti. So we have cotangent squared theta is equal to cosecant squared theta. Then we plus minus 1, sorry. Then 1 is equal to cosecant squared theta minus cotangent squared theta. Okay, so yan ay mga useful na identities. So ngayon, sir, saan galing to? Saan galing yan? So paano na-derive to? Saan na-derive yan? So consider natin si sin squared theta plus cosine squared theta is equal to 1. Okay, so consider natin si sin squared plus cosine squared theta is equal to 1. So pag dinivide ko both side by sin squared, ang mangyari ganito. So kunyari dinivide ko siya by sin squared theta. So mangyari sin squared divided by sin squared 1. Okay, then plus cosine squared over sin squared, that is cotangent. Kasi cosine over sin, di ba sabi ko kanina, sabi ng quotient, cosine over sin is cotangent. Eh naka-square yan, cosine squared over sin squared, that is cotangent squared. That is cotangent squared theta equals 1 over sin squared. So ano yung 1 over sin? 1 over sin is cosecant. Since naka-square, that is cosecant squared. Cosecant squared theta. So na-derive ko siya gamit yun. So next is, consider ulit natin, kunyari dinivide natin sa cosine yan. So si sin squared theta plus cosine squared theta is equal to 1. Dinivide naman natin sa cosine squared. So ang mangyari, yung sin squared over cosine squared, tangent, which is tangent squared. Okay, then cosine squared divided by cosine squared, that is 1. Then 1 over cosine is cosecant or secant squared. Tama, so that is secant secant squared theta. So, kaya sila tinawag na Pythagorean identities. Kasi itong dalawang to, galing lang din dito. In which, silang dalawa, pwedeng ito yung form, pwedeng ito yung form, pwedeng ito yung form, pwedeng ito yung form. Okay, so again yung sin squared, pwedeng 1 minus cosine squared. Yung cosine squared, pwedeng 1 minus sin squared naman. Okay, so, ito lang din dapat. Dapat, papunta sa mindset mo na, dapat magaling ka din mag-manipulate. So, not sa sense na dapat kabisado mo, dapat ito dapat ay I think ano ba yun? Hindi lang basta kabisado, dapat nasa flow na ng mindset mo na kumbaga pag nakita mo to, ito yan, tapos hindi rin right away ito yun. Kunyari nakita mo to, substitute mo. Kung hindi siya kailangan, hindi naman kailangan. So mag-isip ka ng other way para ma-solve natin siya. Okay, so for the next example ko or sa next kong gagawin is mag-example ako into which i-apply ko lang muna sila. So wala mo nang verifying. So ang gagawin ko muna is gagamitin ko yung identities para ma-solve natin yung ibang trigonometric function para malaman nyo na ito ay totoo. Okay, so ito nga apply ko yung mga identities, yung fundamental identities natin para ma-solve itong mga problems dito. Okay, so number 1, if tangent theta is equal to negative 5 over 3 and theta is in quadrant 2, find the value of the other trigonometric function. Okay, so we will use trigonometric identities or yung fundamental identities ng trigo. Okay, so unang start tayo sa tangent theta. So sa tangent theta, saan siya una related? Sir, related po siya sa quotient, yung sine over cosine. Pero hindi sufficient. Tama. Sa sine over cosine lang siya. So I think i-relate natin siya kay cotangent. So note na si cotangent theta. Note that cotangent theta is equivalent kay 1 over tangent theta. Okay? In which this is equal to 1 all over negative 5 over 3. So therefore, what is cotangent theta? Cotangent theta is equal to 3 over negative 5 or negative 5 over 3. So nahanap ko na yung cotangent theta. Okay, next is kung nakikita, alala nyo, si tangent may relation din siya kay secant. Si tangent may relation kay secant. So sa secant daw equivalent kay secant squared equivalent kay tangent squared plus 1. Okay, so pwede ko mahanap yung secant using yan. Okay, so sabi tangent squared theta plus 1 is equivalent kay secant squared theta. Note that tangent squared theta is negative 5 over 3. So this is negative 5 over 3 raised sa 2. So wag kalimutan yan. Then plus 1 equal to kay secant theta. Tapos i-raise ko na sa 2. So ibig sabihin ng secant squared theta, ito lang din yan. Okay, so this is 25 over 9. So this is 25 over 9 plus 1 is equal to secant theta. Tapos square root ko na. Kasi tatanggalin ko rin yun eh. Kasi secant lang na may nahabol ko eh. Okay, then that is equivalent sa 9 plus 1, that is 34, no? So that is square root of 34 over 9 is equal to secant theta. Okay, next, secant theta is equivalent to anong quadrant tayo? Nasa quadrant 2 tayo. Ano yung sign ng secant sa quadrant 2? Ang sign ng secant sa quadrant 2 is negative. Tama, ang sign ng secant sa quadrant 2 is negative kasi cosine sa quadrant 2 is negative. Okay, so ang sign dito ng secant is negative square root of 34 over 3. Square root ko yan. Next, since alam natin na reciprocal si secant sa kasi cosine, pwede ko mahanap si cosine. So paano si cosine? Si cosine theta is reciprocal to. So si cosine theta is just yung reciprocal niya, which is 3 over negative square root of 34. Okay, kasi nga reciprocal lang silang dalawa. Okay, next, ano nang kulang natin? May tangent na tayo, may cotangent, may secant, may cosine. Wala pa tayong cosecant saka sine. So knowing na may cotangent tayo, relation din siya kay cosecant. Tama. So may relation din siya kay cosecant. Si cotangent daw, cotangent squared equal kay cosecant squared. So gamitin din natin identities na yun. So sabi 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, then this is 1 plus cotangent is 3 over negative 5. 3 over negative 5 square is equal to cosecant theta raised sa 2. Okay, then kunin ko na yung square root. This is square root of 1 plus 9 over 25 is equal to cosecant theta na lang. In which that is square root of 34 over 25. Tama, that is square root of 34 over 25 is equal to cosecant theta. Next, cosecant theta is positive sa quadrant 2. So, obviously, cosecant theta natin, so cosecant theta natin is equivalent kay square root of 34 over 5 positive. Okay, since reciprocal si sin sa kasi cosecant, si sin theta is just 5 over square root of 34. So, kahit i-rationalize mo, okay lang naman, or kahit hindi. Okay, so, may other term to, no? Or, lagay ko dito, no? Or, this is 3 square root of 34 over negative 34. Or dito, or 5 square root of 34 over 34. Okay, so therefore nahanap ko na yung other trigonometric function using yung ating identities. So napansin mo, useful. So kung try mo, isolve mo kung yung usual way natin na ginagawa, try mo lang din. Okay lang din naman. Okay, next is number 2. Use the fundamental identities to write tangent theta plus cotangent theta in terms of sin theta and cosine theta and then simplify the expression. Okay, so sabi nga niya dapat daw naka sin theta sa cosine theta lang. So wala nang iba. So anong gagawin? Meron akong tangent theta plus cotangent theta. Using the quotient identities, si sin theta, si tangent theta is sin theta. This is sin theta over cosine theta plus this is cosine theta over sin theta. Next is cross multiply natin, then kunin LCD, sin theta times sin theta, that is sin squared theta plus cosine squared theta all over cosine theta, then sin theta. Okay, then lastly, si sin squared plus cosine squared, that is the Pythagorean identities, which is 1. Okay, so again, si sin squared plus cosine squared, that is 1. So therefore this is equivalent lang, so this is equal sa 1 over cosine theta sin theta. So naka-express na siya in terms of sin theta sa cosine theta. So hindi lang ibig sabihin ganito. Okay, so kasi pag sinabi ng express in sin and cosine theta, tapos hindi ko sinabing simplify, baka ganyan lang gawin mo. Palitan ko lang siya ng ganyan, tapos ka na. Ganyan yung so huwag yung gagawin yan. Okay, next is express cosine x in terms of tan x. So ito baliktad, no? Start tayo sa cosine. So dapat maging tangent x siya. So meaning yung mga term niya puro tangent x lang. Okay, so ano bang mga relation yung pwede natin kunin? So start tayo dito. Meron akong tangent squared theta plus 1 is equal to secant squared theta. Okay, so note na meron akong tangent squared theta plus 1 is equal to secant squared theta. Ngayon, kung meron ako nyan, equivalent din dito yan. Pwede rin sabihin natin na 1 over tangent squared theta plus 1 is equal to 1 over secant squared theta. So again, possible yan kasi identity yun eh. So meaning, yung reciprocal nilang dalawa, identity rin yung dalawang yan. Okay, next is yung 1 over secant. Kung naalala nyo, si 1 over secant natin is 1 over cosine. Tama. So, si 1 over secant, si 1 over secant, ito, si 1 over secant is cosine theta. So, meaning, yung 1 over secant squared theta. So, this is 1 over tangent squared theta plus 1 is equal to cosine squared theta. So, napapansin nyo, may cosine na ako. Sabi nga si cosine daw in terms of tan. So, pag kinuha ko yung square root, this is cosine theta is equal to square root of 1 over tangent squared theta plus 1. So, napansin nyo, si cosine naka-express na in terms of tangent. x. So, since x na pinag-uusapan, gawin natin ganito. This is cosine x is equal to positive negative square root of 1 over tangent squared x plus 1. So, nakadepende yung sign sa kung anong quadrant si x. Okay, so, ito yung ating sagot. Okay, next is for number 4, last para dito. So, suppose cosine theta is equal to x plus 1, x over x plus 1, find sin theta. So, hanap ulit tayo ng relationship ni cosine sa ni sine in terms sa ating identities. So, kung napapansin nyo, saan may relation si cosine sa si sine? Yung mismo silang dalawa lang. Sir, dito po. So, pwede rin po dito. Okay, so in terms dito, given kasi si cosine, okay, since given si cosine, pwedeng ganito gawin natin. Gamitin natin sin squared theta is equal to 1 minus cosine squared theta. Okay, so meaning, we will use yung sin squared, yung identity na, sin squared theta is equal to 1 minus cosine squared theta. Okay, so this is equivalent sa sin theta is equal to square root ng 1 minus cosine squared theta, which is equal, so 1 square root ng 1 minus cosine theta is x over x plus 1, x over x plus 1 raised sa 2. Okay, then kunin natin ng konting simplify natin, so that is equal sa 1 minus x squared over x plus 1 square. Okay, then kunin natin konti yung kanyang something na identity or LCD sa loob. So that is equivalent sa square root ng x plus 1 square minus x squared over x plus 1 square. Okay, next sa ilalim, pwede ko na square root kasi square root ng x plus 1 squared is x plus 1. Okay, so sa taas, simplify ko pa. So this is equivalent sa square root ng x squared plus 2x plus 1 minus x squared. Okay, all over x plus 1 na lang. O, dapat nga x plus 1 na lang, wala na parenthesis eh. Okay, next is, sir, bakit na x plus 1? Kasi square root na x plus 1 squared is x plus 1. Next, this is equivalent sa square root ng 2x plus 1 na lang, all over x plus 1. So, therefore, ito yung kanyang sagot. So, sin theta is equivalent sa square root ng 2x plus 1 over x plus 1. Ayun yung equivalent niya. So, hoping na nakatulong ito. So, kaya ko ito ginawa para magkaroon ka ng konting idea. Ano ba yung identities or ano ba yung proving identities dito sa Trigo? So, napansin mo, nagagamit ko lahat. So, una, yung ginagawa ko is, syempre, tumitingin ako yung mga relationship nila. Okay, so, another thing, fundamental identity sila. So, meaning, pwede ko pang dagdagan yan. Or I think, madadagdagan talaga yan. Marami talaga tong trigonometric identities. Okay, so, thank you for watching. Hoping na panoorin mo yung next video natin.